This is a video for section 8.2. Today we're going to talk about ellipses. And ellipses are also a part of the conic sections unit. In this case, when I take a cross section from the cone, I'm still only going through one nape. I end up, if I go more horizontally, I end up with an ellipse. And it cuts through it here. So what is an ellipse? The definition is a set of all points in the plane whose distances from two fixed points in the plane have a constant sum. So if I take a look, I have two foci. We talked about what the focus was last time, but I still have two foci. The distance from the first foci to the ellipse and the distance to the second foci is constant, meaning it's the same for every single one. So if I went from this foci to this point and that point over, it would be the same constant if I added those distances together. I can also go down here and back, and those distances are going to add up to the same constant value. So anywhere I go along this curve. Now, for some vocabulary, foci, the fixed points on an ellipse, and we already talked about those. You can see in this picture, this is a focus, this is a focus. Now I have two. And just like with the parabola, the focus is inside of the curve. The focal axis is the line through the foci. And that was similar to the parabola too. It cuts it in half. It's kind of our line of symmetry, so to speak. The center is the point on the focal axis midway between the foci. So the center is literally in the middle of both foci and the vertices. And the vertices are the points where the ellipse intersects its axis. And we got formulas for ellipses. And you can see here we're still squaring things, but now we have some other situations in common. Okay, one thing I want to point out in this case is that you'll notice for both x squared and y squared that a squared is below the x squared part. It's also below the y squared part. And so a is the semi-major axis and b is the semi-minor axis. So whichever a is bigger. Okay, so the denominator, the largest denominator, tells me which equation I'm using. If the largest denominator is under the x, then I'm using the equations on the left. If the largest denominator is under the y, I use the equations on the right. And you'll see as we get into problems, sometimes they're going to try to confuse you with that. But just like with parabolas, we have this list of how do I find all of these important values. Focal axis, y equals k, so that is a line. The foci, I have two now.
Good morning,
so
good morning.
I have one plus, you see this plus or minus, because I have two answers. And you might want to make a note of that. Two answers. Same thing with vertices. I should have two, because it's a plus or a minus. Okay? My semi-major axis is A, my semi-minor axis is B, and they come together with the Pythagorean relation. Now this is not the Pythagorean theorem, it's not a Pythagorean identity, it's a Pythagorean relation that happens for ellipses. And it's a squared equals b squared plus c squared. Now why do I care about c? Because c helps me determine where my foci are from my center. And that is not, like I say, not the Pythagorean theorem, not a Pythagorean identity. It's just a relation that we need for this specific formula. Alright, let's look at some problems. So, what do ellipses look like? Okay, kind of an oval. You need to make sure you label all of your parts. So, vertex, focus, center, focus, vertex. And it follows the same. Vertex, focus, center, focus, vertex. Alright, so find the vertices and the foci of the ellipse. Okay, so we're looking at our first one, and we see the larger value 25, is going to be our a. Okay, it's our a squared, which means that y squared is the formula I'm looking for. So on my ellipse, I need to look at the formulas on the right. So, things I need to find: vertices and foci. My vertices are h comma k. So, now it's h plus or minus
all the way down the street, down that hallway, take the last doorways on the right.
is my formula for my vertex. Remember, hk is my center on an ellipse. So on an ellipse, hk equals my center. Now here, I'm centered at 0. So h is 0, k is 0, a squared is 25, so a plus or minus 5. B squared is 21, so b is plus or minus square root of 21. And now we can start plugging things into our formula once we know h, k, a, and b. Alright, we also, though, have to find c. The reason we have to find c is because our formula for foci is h comma k plus or minus c. And so we have that Pythagorean relation. Pythagorean relation is a squared equals b squared plus c squared. Well, c is what I'm looking for. A squared was 25. B squared is 21. C squared equals 4. So C equals plus or minus 2. Now I can plug into my formulas. So V equals H, which is 0, comma, K, so 0, plus minus A. Well, plus or minus 5, which means my 2 points are 0, 5, and 0, negative 5. Okay, then for my foci, 0, comma, 0 plus or minus 2, which means my points are 0, 2, and 0, negative 2. So once I have the vertices and the foci, I've got things going. Right, so we really had to go through and find all of our values. What's H, what's K, what's A, what's B, what's C. So let's go ahead and look at the second one. Alright, so one thing you'll notice on your formula sheet is that all ellipses have to equal 1. But this equation doesn't. So we need to divide everything by 36. Which leaves us an equation. 9 over 36 is 1 over 4. So I have x squared over 4 plus y squared over 9 equals 1. Now, notice that my larger value in the denominator is with the y. So that means it's a y squared equation. So I have to look at the formulas on the right, just like I did on the last example. So to find our vertices, remember we still need to find H, K, A, B, C. Well, I don't have anything added or subtracted to X or Y, so my center is going to be 0, 0. A is the square root of 9, which equals plus or minus 3. B is going to be the square root of 4, which equals plus or minus 2. And C, remember, is that A squared, so 9 equals 4 plus C squared, which means C is the square root of 5, plus or minus. So now I can go ahead and find my values. So my vertex is h comma k plus minus c, which equals h and k were 0, so 0 comma c was square root of 5, and 0 negative square root of 5. My foci is h, k plus or minus a, so 0 comma 3 and 0 negative 3. And those are my points. It's very important that we pay attention to whether or not we have an x squared leading equation or a y squared leading equation, because that's going to tell us which way our ellipse is also going. Right? So let's move on to the next. Find the vertices and the foci of the ellipse. I'm going to have you pause the video and go ahead and attempt the first one on your own, and then come back and check your answer. Go ahead and check your answers. Remember, on our center, whatever is with y is the k, whatever is with x is the h. And now, you'll notice on the second example, we have a leading equation with x. And so go ahead and pause the video again and attempt the second example. Go ahead and check your answers for this one. Notice the only difference is that now, instead of adding and subtracting from k, we're adding and subtracting to h. Okay. Now, we need to sketch the graph of the ellipse by hand. And so when we're sketching the graph, the a and the b actually come into play here quite a bit. And we need our vertices and our center. So, we'll notice that our center is 0, 0. So here's my center. Okay. Now the next thing is A is plus or minus 9. B is plus or minus 5. So from the center, we're going to count over to 9. And to negative 9. And up to 5. And down to 5.
Okay, well, let's just do that then. Let's see.
Okay. Then we draw this box. This is my A. And this will be negative A, positive A.
Okay, thanks.
And this will be B. And negative B. Okay. So now we can draw our ellipse. This is our vertex, center, vertex, and we're going to sketch our ellipse around our box. Now the box is actually going to come into play a lot next time with the hyperbola, so we want to have the idea and understand what's going on. Now it makes sense that our graph is oval along the x-axis because the x squared part had the larger a. That was our semi-major axis. Now the last thing I have to do is I need to put in my foci. And my foci are the plus or minus c part. So remember c, it's a squared, so 81, equals b squared plus c squared. So c equals plus or minus the square root of 56, which is approximately 7.5. So if I go out to about 7.5, I put a dot, that's a focus. I go out here, about 7.5, and that's a focus. And then I have my entire graph labeled. Okay, so we need our center, we need our A, B, and C, we need our foci. And then we can draw our graph. So let's go ahead and we will try example 2. Okay, so now we want to look at example 2. Notice that this is a y squared, because our largest A is with y, which means that my ellipse should follow along the y-axis. So our center, in this case, is 1, 3. Remember, this is K, this is H, and that's the opposite. So I need to find my A, B, and C. A is square root of 49, which is plus or minus 7. B is the square root of 25, which is plus or minus 5. For C, I need to use my Pythagorean relation. So 49 equals 25 plus C squared. C squared is 24. So C is the square plus or minus the square root of 24, which is approximately 4.89. So now I have all my parts, I can go ahead and start my graph. Okay, so let's go ahead and we'll first put our center, so over 1 up 3. This is our center. Now, my focus, I'm sorry, we want to go A. Remember, A is Y, so instead of going left and right 7, I need to go up and down 7. So here is one of my vertices, and this is my A. I go down 7. This is my other vertex, and this is my negative A. Then I also need to find my foci, which is plus or minus just about 5. So this is an F. And go down 5. Or a little bit less than 5. And that's my second focus. Now I need to plot my B. B is plus or minus 5, and this is my semi-minor axis, so it's going left and right. So now I have all this, I need to sketch my graph. And there is my ellipse. Okay. So make sure you pay attention. If your A is with the x squared, your ellipse should be a little more on the x. If A is with y squared, my ellipse should be a little more up and down. Okay. So write the equation. So we've kind of covered, we're following the same order as we did last time. We identified the parts, we drew the graph, now we have to go back to the equation. Alright, so we have identified our parts, we have drawn our graph, now we need to write our equation. So when we write our equations, whether it's an x squared or a y squared, we need h, we need k, we need a, and we need b. Okay? So if we think about what's happening here, right? Major axis length 14 on the x-axis. So if it's on the x-axis, it's right here. That tells me a couple things. First, I'm centered at the origin. So HK is 0, 0. Well, if the length, this whole length is 14, then that tells me that my actual distance for A, this is plus A, This is minus A. So that tells me that A actually equals 7. So A is 7. Because the formula sheet says semi-major axis. Semi-major means half. Or semi means 2. So twice a year. So half of 2 times A will give me the major axis. Alright? Because this half is 7 and this half is 7. So together they make 14. So now when I'm looking at minor axis length is 10, that means up and down here I got B and negative B, and that's 10, which means that B equals 5. Alright? So now I have HK, A, and B. And I gotta figure out, is this an x squared though, or a y squared? Well, my major axis is on the x-axis, which means my ellipse is gonna do something like this. And so it's flatter this way, so it's an x squared. So I go to my formula, x minus h squared over a squared. Remember, a was 7, so this is going to be over 49, plus y minus k squared over b squared. B is 5, so 25, equals 1. So my final equation, x squared over 49 plus y squared over 25 equals 1. So in all cases, we're trying to figure out what's h, what's k, what's a, what's b. We go to the next one. Next example. H, K, A, B. These are the parts I need to find my equation. If I think about drawing my picture, the endpoints of the axes are plus and minus 7, 0, so I have endpoints of my axis is here, and then plus and minus 4. So I got points here and here. Which, if we think back to our box, that means my box goes like this. Well, what that tells me is that this is an x squared, because my ellipse is going to do this again. So, I'm centered at 0. So HK is 0, 0 again. A and B. Now remember, A is how far over I go. So that's 7. B is up and down. So that's 4. And I can go back now and write my equation. H and K is 0. So I'm going to have x squared plus y squared. Skip that step here. And it always equals 1. Now A is 7. So 49. B is 4. So that becomes 16, because remember on our formula it says a squared and b squared. Here's a couple more. So, on these, minor axis endpoints, major axis length. So they're telling us, if we think about drawing it, okay, plus and minus 12, 0, so 2, 4, 6, 8, 10, 12. Now, these are the minor axis endpoints, which tells me that my parabola is going, or my ellipse is going to go up and down. So this is a y squared equation. So remember, I need h, k, a, b. Major axis length is 26. Well, if it's 26 and I'm centered at 0, that means I got to go up to 13. And down 13. So, major axis is 13, minor axis is 12, h is 0, k is 0. We said, because the minor axis is on the x, that tells us I'm going up and down for my major. So y squared plus x squared equals 1. Y squared is now going to get my a. 13 squared is 169. 12 squared is 144. And there's my equation. Go ahead and pause the video and try the next example on your own. Come back and check your answer. So here are my two foci. Now remember, my center is between equal distance between my foci. So there is a length of 4 from here to here, which means my center has to be here in the middle. So I know my center is -2, 3. So I have my h and my k. So the major axis endpoints are -2, -1. There's my vertex. And -2, 7. Vertex. So if you recall, A is the distance from my center to my vertex. So from -2, 3 to -2, 7, that's a distance of 4. So A equals 4. B is going to have to come from a Pythagorean relation. Now remember, my foci gives me C. So C is the distance from the center to the foci, which is 2. So C equals 2. So my relation is A squared equals B squared plus C squared. Well, 4 squared is 16 equals B squared plus 4. Take away 4. B squared is 12, which means B is the square root of 12. But for our purposes, I actually need the actual B. So this ellipse is a y squared ellipse because my focal axis is on a line with the y-axis. So I'm going to have y minus k, which is 3, squared, plus x minus -2 squared. Remember, a goes with the y this time, so 16. B squared was 12, and all that equals 1. You do need to simplify. Make sure your negative is a positive. And there's my final equation. So each time we're finding h, k, a, and b. And sometimes finding a and b is going to require you to go back and figure out c or all sorts of other things. So make sure we pay attention to our formula sheet and our Pythagorean relation. If you recall from parabolas, you had to go back and draw your graphs anyway a little bit to get an idea of how to write your equation. The same holds true here. I need to kind of sketch out what they're giving me so I know if I'm an x squared or a y squared. Please ask your teacher for your exit ticket now. Fill these out, and we will help you out with what you still have questions on. Your homework is page 653, 1 to 39 odds, skip 17 and 19.